Good morning, children. Today's class is on chapter 15, probability, the last topic in class 9 syllabus. Let's read the introduction given in the textbook. Introduction. In everyday life, we come across statements such as, "It will probably rain today," "I doubt that he will pass the test," "Most probably Kavita will stand first in the annual examination," "Chances are high that the prices of diesel will go up," "There is a 50-50 chance of India winning a toss in today's match." So in all these activities or in all these actions, you must have seen the word probably, doubt, most probably, chances, etc. So the uncertainty of probably can be measured numerically by means of probability in many cases. Though probability started with gambling, it has been used extensively in the field of physical science, commerce, biological sciences, medical sciences, weather forecasting, etc. So how this topic was introduced? The topic probability is introduced on an experimental approach. Let's define the terms. What is the meaning of an experiment? An experiment means an activity. It is only an activity which results in a well-defined end. The examples of any experiment under consideration are toss a coin or throw a die or playing of cards. These are all examples you can take for an experiment. When you perform an experiment, definitely there will be some results. Those results we call it as outcomes, and there are many results in certain experiment. Let's take the examples, or what can we say about the examples for outcomes? When you toss a coin, the possible outcomes are head or tail. There are two outcomes or two results. When you throw a die, 3, 4, 5, 6. There are 6 outcomes here or 6 results, and those results we call it as outcomes. Similarly, when you play with a deck of cards, there are 52 outcomes or 52 results. That is, outcome means the total number of results is called an outcome. Now, what is the meaning of trial? When you are asked to toss a coin 10 times, the toss a coin will show the experiment. Each toss is named as a trial, and each trial will give you a result. Imagine in the first toss of the coin, the head shows up. That means the head which has come up is a particular outcome, and that particular outcome is called as an event. So what is the definition of a trial? An action which results in one or several outcomes is called a trial. A collection of some outcomes of the experiment is termed as an event. That is, each toss of the coin is called a trial. A trial will give you a result. That means in the first trial, if the result is head, that particular outcome is called as an event. So based on all these definitions, the formula or the statement for the probability of an event is defined. Let E represents an event in a particular experiment. Then the probability of that event is given by P of E is equal to number of trials in which the event E happened divided by the number of trials. This is the basic formula or statement you should write in any questions related to probability. That means probability of an event is equal to number of trials in which the event E has happened divided by total number of trials. As an example, you are asked to toss a coin 10 times. That is the total number of trials. Here the total number of trials is equal to 10. Now the particular event is how many times head turned up. Let's rewrite number of heads is equal to 3 and number of tail equal to 7. So now you are asked to write the probability that number of times the head turned up. So the number of times the head has turned up has become the event. That is 3 times heads turned up and 7 times tail turned up. So let E be the event on head. Therefore, probability of E is equal to 3 divided by the total number of trial is equal to 10. If you get a fraction, if you can simplify, leave the answer always in the simplified form. Let's review on the terms. What is an experiment? An activity which results in a well-defined end. What is or what are outcomes? Total number of results is called an outcome, or they are called as outcomes. Trial, an action which results in one or several outcomes. Event, a collection of some outcomes of the experiment. And what is the definition of probability? Probability of an event is equal to number of trials in which the event E occurred divided by the total number of trials. If you take the example as I have explained the previous case, the total number of trial is equal to 10. The number of times head turned up is equal to 3. Number of times tail turned up is equal to 7. Probability of head, we got it as 3 by 10, and the probability of tail is 7 by 10. If you add the probability of both the events, you can see it is 3 by 10 plus 7 by 10, which is the same as 10 by 10, which is equal to 1. That is the sum of all the probability of all events in an experiment. That means when the experiment is of tossing of coin, the sum of all the probabilities of all the events that is possible in that experiment is always 1. Therefore, the probability of each event will always be lying between 0 and 1. Exercise 15.1. First question. In a cricket match, a batswoman hits a boundary 6 times out of 30 balls she plays. Find the probability that she did not hit a boundary. So that means from the question itself, the total number of trials, that is 30. Then the event in which the ball hit a boundary is 6. Therefore, the event in which the ball did not hit a boundary is 30 minus 6, which is equal to 24. E represents the event. Let E be the event where the ball did not hit a boundary. Therefore, probability of E is equal to number of trials in which E happened by total number of trials, which is equal to in which E happened, did not hit a boundary. As we explained, it is 30 minus 6 by the total number of trials is 30. It is 24 by 30. If possible, you have to always reduce. Reduce with 6. 6 fours are and 6 fives are 30. Each question you must write the statement for the exam. Here we will write only the fractions. Question number 2. 1,500 families with 2 children were selected at random and the following data was recorded. Compute the probability of a family chosen at random having 2 girls. The table shows the number of girls in a family, against it 210. Number of families 475, 814 and 211, which is totaling to 1,500. Compute the probability of a family chosen at random having 2 girls. So even you can represent the answer as probability of 2 girls is equal to, what is the fraction here? It is 475 divided by 1,500. Reduce the fraction. Then the second one, probability of 1 girl is equal to, under 1 girl you can see 814 by 1,500, and the probability with no girl or 0 girl is the same as 211 by 1,500. Both of this simplify, reduce or simplify to the lowest terms. Question number 4. 3 coins are tossed simultaneously 200 times with the following frequencies of different outcomes. Outcomes are 3 head, 2 head, 1 head and no head, and the frequencies 23, 72, 77 and 28. If 3 coins are simultaneously tossed again, compute the probability of 2 heads coming up. You can just see the data there. Probability of 2 heads is equal to, probability of 2 heads is equal to, it is always a fraction. Under 2 heads there are the frequency is 72 divided by 3 coins. The total frequency is 200. You can reduce with 2, 36 by 100, 18 by 50 or 9 by 25. Then question number 5. An organization selected 2,400 families at random and surveyed them to determine a relationship between income level and number of vehicles in the family. The information gathered is listed in the table below. There are 5 slabs and vehicles per family as per 0 vehicle, 1, 2 and more than 2 vehicles. Suppose a family is chosen. Find the probability that the family chosen is earning rupees 10,000 to 13,000 and owning exactly 2 vehicles. You have to just take the column as 13,000 to 10,000 to 13,000, and under that 2 vehicles, the number frequency is given as 29. So the first one answer, the probability of that particular event is 29 by 2,400. Then earning rupees 16,000 or more, that means the last slab, and owning exactly 1 vehicle. The number given there is 579. Probability of that event is 579 by 2,400. The third one, earning less than 7,000 per month and does not own any vehicle. That means earning less than 7,000 means the first number there, the first slab, and no vehicles means there are 10. That means probability of the event is equal to 10 by 2,400. The fourth one, earning 13,000 to 16,000 per month and owning more than 2 vehicles, that is 2, 3. The fourth slab and above 2, that is 25. Probability of the event is equal to 25 by 2400. Question number 5. Owning not more than one vehicle means, a maximum of one vehicle means it can be either one vehicle or zero vehicle. So what will be the total of, in all the slabs, the number of the people who are not having more than one vehicle, owning one vehicle or below means you have to add the numbers in the zero vehicle as 10 plus 1 plus 2 plus 1 plus that one vehicle column 160, 305 plus 535 plus 469 plus 579. That means probability of that particular event, the fifth answer will be a total of 2062 divided by 2400. Any of these fractions, if you can simplify, leave the answer always in the simplified form. Question number 7. To know the opinion of students about the subject statistics, a survey of 200 students was conducted. The data is recorded in the following table. Find the probability that a student chosen at random like statistics. So the first event is the number of students who is liking the subject statistics. Probability of that event is, who like is 135 divided by 200. And automatically who dislike, probability of that particular event is 65 by 200. Question number 8. Refer to question 2 in exercise 14.2. Question 2 in exercise 14.2. The table is given there. 14.2. What is the empirical probability that an engineer lives less than 7 km from her place of work? So the probability of that event, less than 7 km means how many people are at a distance who's willingly living, how many engineers who would like to stay less than 7 km. When you count the number, you will be getting less than 7 km, the number of engineers as 9 by 40. We have taken as less than 7 km, which shows that 7 km is not counted in this particular thing. More than or equal to 7 km from the place of work is the second one. More than or equal to 7 km, which shows that 40 minus 9, that is 31, the remaining set of engineers. Within half kilometer from a place of work, there is no one. So the probability of that event is 0 by 40, or it is 0. This completes chapter 15, probability. By this, all chapters of class 9 syllabus is completed. I hope you students benefit from the videos, and I wish all the students all the best in your exams.